Hi, in this video we are going to discuss valence bond theory. This is one of most important theory in inorganic chemistry, and this is developed by Hattler and London in 1927. This theory is based on orbital and quantum mechanics. According to this theory, these are half-filled orbital valence electrons which overlap and form covalent bond. As this theory focuses on the formation of covalent bonds. For example, we have two hydrogen atoms which have half-filled orbitals, and at infinite distance there is no interaction between these hydrogen atoms. When these two hydrogen atoms come close together, their half-filled orbital overlap and form covalent bond. And when these atoms come close at the distance of 74 picometer, which is the bond distance, they release energy. This is because at this distance the attractive forces will develop between positive or negative charge, or between nucleus or electrons become dominant over repulsive forces which develop between electrons or protons. And as the attractive forces become dominant or increase, this leads to bond formation or stability of the system by releasing energy. And the second approach is the quantum mechanics. As we know that electrons have dual nature, having wave or particle-like nature. Electrons are macroparticles which having significance waves, and the quantum mechanics deals with such type of particles. According to valence bond theory, these waves of the valence electron in half-filled orbitals which overlap and form covalent bond. This wave function of electrons is denoted by psi, and its value comes from the Schrödinger wave equation. This psi or wave function of electrons have no physical significance, but when we take the square of this psi square helps in finding electron as increase the probability of finding electrons. This psi square gives shape to orbitals, and as we know that the orbitals are the space where the probability of finding electron is maximum. Let's suppose this is the wave function of an electron along x-axis. And when we take the square of this psi or wave function, then the probability of finding electron increase, as the amplitude of this wave increase, and this is the amplitude of the waves which give the probability of finding electrons. And there is a point where the amplitude is maximum. This is a place or the point where the electronic probability density is also maximum. And those points which have amplitude minimum, where the probability of finding electron is also minimum. And those points which have zero amplitude, these points are also known as nodes, where the probability of finding electron is zero. For example, we have two hydrogen atoms A and B. These hydrogen atoms have their valence electrons or have their wave functions. And when these atoms come close together, their wave function overlap and form covalent bond. After combining or forming covalent bond, we can write their wave function in this way. the electrons of the A and B atom become indistinguishable. This wave function have two parts and having two possibilities about electrons. The first part of the equation represents the electron of the A atom remains close to the nucleus of A atom, and the electron of the B atom remain close to the nucleus of B atom. The second part of this equation represents the electron of the B atom remains close to the nucleus of A atom, and the electron of the A atom remains close to the nucleus of B atom. So, in this way, the electrons become indistinguishable. And when we take the square of this equation, we can write the square of psi in this way. In this psi square equation, this third term is the cross term. This shows the constructive overlapping of waves of electrons. As by constructive overlapping of waves of different electrons in different atoms, the electronic density between two nuclei increase. And as the electronic density between two nuclei increase, the bond becomes stronger. This is actual reason behind valence bond theory bond formation of covalent bond. The waves of the electron can overlap or can combine in two different ways. One is the constructive and other the destructive way. In constructive overlapping, the same sign of the waves overlap. For example, we have two waves of two electrons which are in same phase. When these waves overlap, this increases the amplitude or increase the electronic density between two nuclei. As the electronic density between two nuclei increase, this leads to stability of bond. This is a way of formation sigma bond which have maximum electronic density between two nuclei. And in destructive overlapping, opposite sign of the wave overlap. Let's suppose we have two waves of two electrons, which are out phase not in one phase. When these waves overlap, subtract the amplitude and generate nodes. In this way of overlapping, the electronic density is not lie between two nuclei as in constructive way. And as this way of overlapping generate nodes, where the probability of finding electron is zero, and as the node increase, this lead to instability of the system. In fact, this is a way of formation of sigma star which have higher energy and not stable. There is also unique contribution in covalent bonds, as there are possibilities that the both electrons goes to atom A. And the both electrons goes to atom B. So there is improved wave function which is also known as ionic covalent resonance. The improved wave function have covalent bond character plus ionic bond character. Here, the value of C represents the unique character mixed in covalent valence bond structure. The actual value of C is about 0.25, which indicates that the unique structure contributes about 6% to the overall structure of H2 molecule. Let us now we discuss different conditions of valence bond theory or the covalent bond formations. According to valence bond theory, these are the valence orbital which should overlap during bond formation. And these valence orbitals should be half-filled. Or on quantum mechanics we can say these are the waves of the valence electrons which should overlap by constructive way while formation of covalent bond. Or the phase of valence orbitals which are overlapping should be same. Spin of electrons after overlapping should be opposite. Two electrons should have different values of spin quantum number. For example, when two half-filled orbitals of hydrogen atoms overlap and form covalent bond. After overlapping or formation of covalent bond, these have electrons which have opposite spin quantum number. For overlapping or formation of covalent bond, atoms should become close to enough, where the attractive forces should be greater than repulsive forces. And according to valence bond theory, there should be proper alignment or symmetry of valence orbitals which are going to overlap. Valence orbitals can overlap head-to-head or side-to-side. In head-to-head overlapping, sigma bond form, which is a bond in which electronic density is maximum or concentrated along the internuclear axis. For example, when two s orbitals overlap and form sigma bond. Here the electronic density is maximum between two nuclei, and we can represent in this way. When s and p orbital overlap, they also form sigma bond, and here the electronic density is also maximum between two nuclei, and we can represent this in this way. And when two p orbitals overlap head to head and form sigma bond, here the electronic density is also maximum between two nuclei, and we can represent in this way. For example, in hydrogen fluoride molecule, sp orbital overlap and form sigma bond. Hydrogen atom has half-filled s orbital and fluorine atom has half-filled p orbital. These half-filled s and p orbitals overlap and form sigma bond or covalent bond between hydrogen and fluorine atom. We can represent this overlapping in this way. And when valence orbital overlap side to side, they form pi bond. This is a bond in which electronic density lie above or below the internuclear axis. For example, when two p orbitals overlap side to side, here the electronic density is above or below the internuclear axis or above or below the nuclei. This also forms a nodal plane. where the probability of finding electron is 0. For example, when we discuss oxygen molecule, in oxygen molecule, each oxygen atom has two half-filled p orbitals. Two half-filled orbitals overlap head-to-head and form sigma bond. And other two half-filled p orbitals overlap side to side and form pi bond. In this way, oxygen molecule form one sigma bond and one pi bond, which we can represent in this way. So, on the base of overlapping of valence orbitals, there are two types of the bond. One is the sigma and other is the pi bond. Sigma bond is stronger as compared to pi bond. This is because in sigma bond the electronic density is maximum between the two nuclei, and sigma bond has no nodal plane. While on the other hand, the pi bond is the weaker. In pi bond, the electronic density is above or below the two nuclei or internuclear axis, and pi bond has nodal plane. In the next video, we will discuss hybridization, which is extension of Valence bond theory. Thanks for watching and please comment if you have any question.